All right, today we are diving deep into one of the weirdest, most powerful, and just plain mind-bending ideas in all of science, quantum entanglement. This is a story about a huge disagreement between some of the smartest people who ever lived, and it's a mystery that took nearly a century to solve. And we're going to start with the man himself, Albert Einstein. He famously couldn't get on board with a key piece of quantum mechanics. He called it spooky action at a distance. And honestly, that one phrase perfectly captures the epic scientific debate that was about to unfold. So what is this spooky action he was so worried about? Well, to get our heads around it, we're going to use this really great analogy that the physicist John Stuart Bell came up with. It involves a professor and his socks. Okay, so imagine this professor, Professor Bertelmann. He has one simple rule. He never wears matching socks. So if you happen to see that his left sock is blue, you know without a shadow of a doubt that his right sock is not blue. There's nothing spooky here, right? The sock colors were already decided when he got dressed in the morning. It's just simple, logical deduction. But here's where it gets quantum. Entangled quantum socks are different. Before you look at them, they don't have a color. They're just a cloud of possibilities. But the very instant you measure one, and let's say it snaps into reality as blue, the other one, even if it's on the other side of the galaxy, instantly becomes not blue. The act of looking at one immediately defines the other. That is the spooky link. And that instantaneous connection, the idea that poking a particle over here could instantly affect another one light years away, that's what really bugged Einstein. It bothered him so much that back in 1935, he and a couple of colleagues wrote a famous paper arguing that this whole thing proved quantum mechanics had to be missing something. You see, Einstein's whole picture of the universe, which he called local realism, rested on two ideas that, let's be honest, feel like common sense. First, realism. The sock has a definite color even when no one's looking. Second, locality. Nothing can travel faster than light, so what happens here shouldn't instantly affect something way over there. Entanglement seemed to just tear both of those ideas to shreds. And this wasn't an argument that got settled quickly. Just look at this timeline. We go from a philosophical head-scratcher in 1935 to a mathematical test in the 60s to a real-world experiment in the 80s, and finally, a Nobel Prize for it all almost 100 years later. This was a true marathon of scientific discovery. For nearly 30 years, this was just a debate. You had Team Einstein on one side and Team Quantum on the other, with no real way to prove who was right. Then, in 1964, an Irish physicist named John Bell came up with a brilliant idea, a test that could actually ask nature itself for the answer. So, the setup he imagined goes something like this. You create thousands of these entangled pairs of particles. You send one from each pair to observer Alice and the other to observer Bob, who are far apart. Now, here's the crucial part. Alice and Bob each randomly flip the settings on their measurement devices at the very last second. This is super important because it ensures the particles can't have some kind of prearranged secret plan. What Bell did that was so genius was he turned this big philosophical question into a math problem. He actually calculated the absolute maximum amount of correlation Alice and Bob could ever find if the universe followed Einstein's non-spooky rules. And that number is 2. According to what we now call Bell's inequality, if the universe has no spooky action at a distance, the final correlation score between all of Alice and Bob's measurements just can't be higher than 2. Ever. It was a line in the sand. But, and this is a big but, quantum mechanics predicted something totally different. It said that because of spooky entanglement, the correlations could be way stronger, reaching a score as high as 2 times the square root of 2, which is about 2.82. The challenge was set. Go do the experiment and see which number pops out. Of course, it's one thing to come up with the theory. It's another thing to actually build the experiment. It took nearly another 2 decades for technology to get good enough. But in the early 1980s, a team in France led by physicist Alain Aspect finally pulled it off. And the results were, well, they were completely unambiguous. Their experiment consistently smashed past the limit of 2. The quantum prediction was right. The universe really is spooky. And on this one, very fundamental point, Einstein's incredible intuition had been wrong. And for this absolutely groundbreaking work that literally changed our understanding of reality and kicked off a whole new field of technology, Aspect and his colleagues were awarded the Nobel Prize in Physics in 2022.
But hold on, the story isn't over. Because that's not how science works. You have to be absolutely sure. So for the next 40 years, physicists became the ultimate skeptics, working like crazy to close every single loophole they could think of that might have faked those spooky results.
They closed what's called the locality loophole. What if the detectors were somehow signaling each other? By moving them miles apart. They closed the detection loophole. What if the machines were just inefficient and biased? By building much, much better detectors. But that left one last, almost philosophical problem, the so-called free will loophole. What if the universe was somehow conspiring to predetermine the random choices the scientists were making, just to trick them? So, how on earth do you prove your choices are truly random? Well, you outsource the choice to the cosmos itself. In a truly incredible experiment, scientists use light from ancient quasars on opposite sides of the known universe to choose the detector settings. Since these quasars haven't been able to influence each other since the Big Bang, there's no way they could be part of some local conspiracy. And this quote from MIT physicist David Kaiser just perfectly captures the spirit of it all. "Let's go for broke," he said. And they did. When this cosmic bell test was run, the results were the same. The universe is, without a doubt, spooky. Okay, so this is all incredibly fascinating. But you might be thinking, why does any of this matter to me? Well, it matters because what started out as a philosophical argument is now fueling a massive technological revolution. You see, the first quantum revolution gave us things like lasers and transistors, the building blocks of our entire digital world. This second quantum revolution, as Nobel laureate Ellen Aspect calls it, is all about taking these spooky phenomena like entanglement and actually building brand new technologies with them. And we're not talking science fiction anymore. Entanglement is the engine that's going to power quantum computers capable of designing new medicines and materials. It's the backbone of a future quantum internet. And get this, it's the key to creating communication systems that are perfectly, fundamentally unhackable. So, what began as Einstein's spooky action at a distance has been proven beyond all reasonable doubt to be a real core feature of our universe. It turns out reality is not just stranger than we imagine, it might be stranger than we can imagine. And that just makes you wonder, what other incredible secrets is the universe just waiting for us to uncover?